Art. Good evening, everyone. Welcome to Victory Online Academy. Let me introduce myself first. My name is David from Chemistry Faculty of Victory Online Academy. I've been teaching chemistry for 7 years. Now, I am teaching Igcse, AS, and A-level chemistry. I'm going to explain about stoichiometry today. These are our learning objectives today. Use the molar gas volume taken as 24 cubic decimeters at room temperature and pressure, or RTP, and calculate stoichiometric reacting masses, volumes of gases and solutions, and concentrations of solutions expressed in mole per cubic decimeter. Stoichiometry is calculations that involve chemical reaction. Every time you deal with stoichiometry, you have to use balanced chemical equation or reaction. If the chemical reaction is not balanced yet, you have to balance it first. Today, you are going to understand the term mole, the relationship between mole and mass, the relationship between mole and volume of gas measured at RTP or room temperature and pressure, and the concentration of solution in mole per cubic decimeter. And we are going to solve 2 or 3 questions about calculations that involve chemical reactions. Let's start with term mole. What is mole anyway? Mole is a unit for particles. Mole is a unit for particles. Remember, particles can be atom, ion, and molecule. Mole is similar to gram, kilogram, liter, and milliliter. Gram is a unit to represent mass. Liter is a unit to represent volume, while mole is a unit to represent number of particles. 1 mole contains 6.02 times 10 to the power of 23 particles. This is called Avogadro constant. So, from this one, we know that there is a lot of particles in 1 mole of substance. Next, let's talk about mole and mass. We can find the number of moles from mass and vice versa using this equation. Moles equals to mass divided by AR, or moles equal to mass divided by MR. In this case, the mass must be in grams. AR and MR do not have unit. Let's see the difference between AR and MR. AR stands for relative atomic mass. It's an average mass of an atom compared to the mass of C12 atom. You can find the value of AR on the periodic table. Let me show you the periodic table. This one. This is the periodic table. On the periodic table, you see atomic symbol. So for example, this one. This is an atomic symbol for beryllium. Be is an atomic symbol of beryllium. And there are 2 numbers. So once again, on the periodic table, you see atomic symbol and 2 numbers. This is the atomic symbol and there are 2 numbers. The greater one is AR of an element. In this case, the AR of beryllium is 9, while the smaller one is an atomic number. In this case, the atomic number of beryllium is 4. So once again, the greater one represents AR of an element, and the smaller one represents atomic number. In this case, the AR or relative atomic mass of beryllium element is 9, while the atomic number of beryllium element is 4. For hydrogen element, the AR value is the same as the atomic number. Let's talk about MR. MR stands for relative molecular mass. It's an average mass of a molecule compared to the mass of C12 atom. MR can be found by adding all of the AR values of elements multiplied by number of atoms. So once again, MR can be found by adding all of the AR values of elements multiplied by number of atoms. So for example, I have water molecule. Water has a chemical formula of H2O, and I want to calculate the MR of H2O. In water molecule, there are 2 hydrogen atoms and 1 oxygen atom. Okay, now let's try to calculate the MR of H2O. We have 2 hydrogen atoms here, so 2 times AR of hydrogen plus 1 oxygen atom, 1 times AR of oxygen. Okay, let's see the AR value of hydrogen and oxygen from the periodic table. The AR value of hydrogen is 1, and the AR value of oxygen is 16. So let's substitute the values into this equation. Two times 1 plus 1 times 16. 2 plus 16, it's 18. So the MR of water molecule is 18. Okay, next. Next, I have calcium nitrate. This is the chemical formula of calcium nitrate, and I want to try to calculate the MR value of calcium nitrate. Given AR of calcium is 40, AR of nitrogen is 14, and AR of oxygen is 16. If the AR values of elements are not given, you have to find it. You have to find them from the periodic table. In this case, the AR values of elements are already given. The AR value of calcium is 40, the AR value of nitrogen is 14, and the AR value of oxygen is 16. Okay, let's calculate the MR value of calcium nitrate. We have 1 calcium atom here, so 1 times AR of calcium plus we have 2 nitrogen atoms here, so 2 times AR of nitrogen plus we have 2 times 3, 6 oxygen atoms here, so 6 times AR of oxygen. 1 times 40 plus 2 times 14 plus 6 times 16. So 40 plus 28 plus 96. So the MR value of calcium nitrate is 164. Let's continue. The relationship between mole and volume of gas measured at RTP, or room temperature and pressure. We can find the volume of gas from the number of moles and vice versa using this equation. Moles equal to volume of gas measured at RTP, or room temperature and pressure, divided by 24. 24 is a constant, and in this case the volume of gas must be in cubic decimeter or liter. The volume of gas is measured at RTP, room temperature and pressure, at 25 Celsius degree and 1 atmosphere. For example, calculate the volume of 2 moles of helium gas. So let's use this formula or equation. Moles equal to volume divided by 24. So volume equals to moles, number of moles, times 24. 2 times 24, it's 48. Remember, once again, in this case, the volume must be in cubic decimeters or liter. So the answer is 48 cubic decimeters. Next, calculate the volume of 2 moles of nitrogen gas. We have to use the same equation or formula. Volumes equal to number of moles times 24. So 2 times 24 is 48 cubic decimeters or 48 liters. From the example, we can conclude that the volume of gas doesn't depend on the type of gas. As long as they have the same number of moles, the volume will be the same. Next, let's talk about concentration of solution in mole per cubic decimeter. Let's talk about solution first. Solution consists of solute and solvent. Solute is a substance that's being dissolved. Substance that is being dissolved. While solvent is a substance that can dissolve another substance. For example, salt solution. Salt solution consists of salt as solute and water as solvent. Water is a common solvent. There is a lot of solvent besides water, such as benzene, chloroform, ethanol, and etc. In Igcse, concentration of solution is expressed in mole per cubic decimeter. It's defined as number of moles of solute dissolved in 1 cubic decimeter of solution. So I write here, concentration in mole per cubic decimeter is number of moles of solute dissolved in 1 cubic decimeter of solution. Let me create a new page first. Okay. Concentration of solution equals to mole divided by volume. Once again, concentration of solution equals to number of moles of solute divided by volume of solution. In this case, the volume of solution must be in cubic decimeter or liter. If I have 2 mole per cubic decimeter of sodium chloride solution, it means that there are 2 moles of sodium chloride in 1 cubic decimeter of solution. In this case, water as solvent and sodium chloride as solute. If I have 1 mole per cubic decimeter of hydrochloric acid solution, it means that there is 1 mole of hydrochloric acid in 1 cubic decimeter of solution. In this case, water as solvent and hydrochloric acid as solute. Let me give you an example of calculation about concentration of solution in mole per cubic decimeter. How many grams of sodium hydroxide crystals must be dissolved to make 100 cubic centimeters of 1 mole per cubic decimeter sodium hydroxide solution? So once again, how many grams of sodium hydroxide crystals must be dissolved to make 100 cubic centimeter or milliliters of 1 mole per cubic decimeter sodium hydroxide solution? So we have to find the mass of sodium hydroxide crystals that must be dissolved to make 100 cubic centimeters of 1 mole per cubic decimeter sodium hydroxide solution. The formula is this one. Concentration of solution equals to mole divided by volume of solution. Moles of solute divided by volume of solution. In this case, the solute is sodium hydroxide and the solvent is water. The concentration is 1. We want to produce 1 mole per cubic decimeter of sodium hydroxide solution. This is the concentration of the solution. And we need to find the number of moles of solute first. And the volume of solution is 100 cubic centimeter. Remember, the volume of solution must be in cubic decimeter. It's still in cubic centimeter, so we have to convert this one into cubic decimeters. 100 divided by 1000. From cubic centimeter into cubic decimeter, it must be divided by 1000. The result is 0.1 cubic decimeter. So the number of moles of solute equals to 0.1 times 1. It's 0.1 mole. It's not finished yet. It's still moles. We have to find the mass of sodium hydroxide crystals that must be dissolved. So from moles into mass, we have to find mass from mole. We have this formula, moles equal to mass divided by mR, the one that we learned before. In this case, the mR of sodium hydroxide is 40. You can find the mR of sodium hydroxide by adding all of the AR values of elements multiplied by number of atoms. You can find the AR values of elements from the periodic table. In this case, the AR value of sodium is 23, the AR value of oxygen is 16, and the AR value of hydrogen atom is 1. So 23 plus 17 is 40. The MR value of sodium hydroxide is 40. So mass equals to mole times mR. The mole is 0.1 and the MR of sodium hydroxide is 40. The answer is 4 grams. So 4 grams of sodium hydroxide crystals must be dissolved to make 100 cubic centimeters of 1 mole per cubic decimeter sodium hydroxide solution. Okay, let's talk about stoichiometry. Stoichiometry is a calculation that involves chemical reaction, as I mentioned before. So in this case, you need a balanced equation or balanced chemical reaction. Once again, if you are given balanced equation, you can do stoichiometric calculation. But if you are given equation and the equation is not balanced yet, you have to balance it first. That's the point. So in this case, you have to use balance equation or balance chemical equation, balance chemical reaction. Okay. You have to understand the basic concepts of moles first, and then you can do stoichiometric calculation. I have an example of calculation. Okay, bioethanol can be used as a biofuel. It's a renewable resource produced by fermentation of glucose as shown below. So this is the reaction of fermentation of glucose. Glucose is fermented by yeast to produce carbon dioxide and ethanol or bioethanol. The question is, calculate the number of moles of glucose. Calculate the number of moles of glucose needed to produce 10 moles of ethanol or bioethanol. The MR of bioethanol and glucose are given. Let's check the chemical equation first, the chemical reaction first. Is it already balanced? Remember, to balance the equation, you have to make sure that the number of atoms on the left and right sides are the same. Okay, so once again, to balance the equation, to balance the chemical reaction, you have to balance the number of atoms on the left and right sides. It means that the number of atoms on the left and right sides must be the same. Okay, let's check first. This is already balanced or not. So let's see. The number of carbon atoms on the left side is 6. Okay, let's check the number of atoms. Let's check the number of carbon atoms on the right side. 2 plus 4, 6 also. And how about the number of hydrogen atoms? There are 12 hydrogen atoms on the left side. Okay. How about the number of hydrogen atoms on the right side? 5 plus 1 times 2. 5 plus 1 times 2. 6 times 2 is 12. Okay, now let's check the number of oxygen atoms. The number of oxygen atoms on the left side is 6. Let's check the number of oxygen atoms on the right side. 2 times 2, 4 plus 2. It's 6. So we can say that this equation, this chemical reaction is already balanced because the number of atoms on the left and right sides are already same. They are already the same. They have the same number of atoms on the left and right side. Remember, to balance the equation, you may change the reaction coefficient only. The reaction coefficient is the number in front of the chemical formula. So once again, to balance the equation or chemical reaction, you may only change the reaction coefficient. Reaction coefficient is the number in front of the chemical formula or number in front of the substance. In this case, the reaction coefficient of CO2 is 2. The reaction coefficient of ethanol is 2. And the reaction coefficient of glucose is 1. 1, no need to be written. Okay. You may not change the chemical formula when balancing chemical reaction. So remember, you may not change the chemical formula when balancing equation or chemical reaction. Okay, this equation is already balanced, so now we can answer this question. Calculate the number of moles of glucose needed to produce 10 moles of bioethanol. Calculate the number of moles of glucose needed to produce 10 moles of ethanol. Okay, so given 10 moles of ethanol, this one. Remember, every time you do stoichiometric calculation, you have to start with mole and end with mole. Okay? Remember, once again, when you do stoichiometric calculations that involves chemical reactions, you have to start with moles and end with moles also. Okay, let's check. We have 10 moles of ethanol, and now we have to calculate the number of moles of glucose needed to produce 10 moles of ethanol. To find the number of moles of glucose, we can use ratio of reaction coefficient. In this case, the ratio of reaction coefficient of glucose and ethanol is 1/2. So 1/2 times the mole of ethanol, 10. The answer is 5 mole. So once again, to find the number of moles of glucose, we have to use ratio of reaction coefficient of glucose and ethanol. The ratio of reaction coefficient between glucose and ethanol is 1/2. The mole given is 10. So 1/2 times 10, it's 5. Or you can use this formula. Reaction coefficient of substance with unknown mole divided by reaction coefficient of substance with known mole times mole given. Okay, so 1/2 times 10. It's 5 moles. So we need 5 moles of glucose to produce 10 moles of ethanol. Okay, let's try 1 or 2 questions. Okay, this is exam style question. This is IGCSE exam style question. I crop it from past paper. Okay, in this case, we have equation. Copper 2 sulfate crystals are made by reacting copper 2 carbonate with dilute sulfuric acid. The equation for the overall process is shown below, this one. Here are the steps to produce copper 2 sulfate pentahydrate salt. The question is calculate the maximum mass of copper 2 sulfate crystals that can form using the following steps. The first step is calculate the number of moles of sulfuric acid in 50 cubic centimeters of 0.05 mole per cubic decimeter of sulfuric acid. In this case, concentration and volume of solution are given. And now we have to find the number of moles. So we have to use equation or formula that represents the relationship between moles and concentration. So concentration equals to mole divided by volume of solution. Once again, concentration equals to moles of solute divided by volume of solution. In this case, we have to find the number of moles. The concentration of solution and volume of solution are given. So number of moles equal to concentration times volume. The concentration is 0.05 and the volume of solution is 50 cubic centimeters. Remember, the volume of solution must be in cubic decimeter. So it must be divided by 1000. 0.05 times 10 divided by 1000. The answer is 2.5 times 10 to the power of minus 3 moles. Next. Determine the number of moles of copper 2 sulfate pentahydrate that can form. Okay, so we have found the number of moles of sulfuric acid. This one, we have found the number of moles of sulfuric acid. It's 2.5 times 10 to the power of minus 3 mole. And now we are asked to find the number of moles of copper 2 sulfate pentahydrate. Use the ratio of reaction coefficient between copper 2 sulfate pentahydrate and sulfuric acid. The ratio of reaction coefficient is 1 over 1. 1, 1. So they have the same reaction coefficient in this case. 1 divided by 1 times mole of sulfuric acid. So the answer is 2.5 times 10 to the power of minus 3 mole. In this case, they have the same number of moles because they have the same reaction coefficient. Okay, next. The MR of copper 2 sulfate pentahydrate is 250. Calculate the maximum mass of copper 2 sulfate pentahydrate that can form. So we have to find the maximum mass of copper 2 sulfate pentahydrate that can form. We have to use this formula, moles equal to mass divided by MR. To find mass, we have to multiply moles by MR. The number of moles of copper 2 sulfate pentahydrate is already found in the previous part. This one. This is the moles of copper 2 sulfate pentahydrate, 2.5 times 10 to the power of minus 3 mole. and the MR is 250. So the answer is 0.625 gram. Okay, this is the last question that we are going to discuss. The equation for the decomposition of sodium azide is shown below. Sodium azide is decomposed into sodium metal, sodium liquid, and nitrogen gas. Calculate the mass in grams of sodium azide needed to produce 144 cubic decimeters of nitrogen using the following steps. Calculate the number of moles in 144 cubic decimeters of N2 measured at room temperature and pressure. So this is the volume of nitrogen gas measured at RTP. To find the mole, we have to use this formula. Moles equal to volume of gas measured at RTP divided by 24. Remember, the volume of gas must be in cubic decimeters. So 144 divided by 24, 6 moles. So the answer is 6. The moles of nitrogen is 6 mole. And determine the number of moles of NaN3 needed to produce this number of moles of N2. The moles of N2 is 6 mole. And now you have to find the number of moles of NaN3 needed. So we have to use the reaction coefficient. We have to use the ratio of reaction coefficient between NaN3 and N2. 2 over 3 times 6. It's 4 mole. So the number of moles of NaN3 needed to produce 6 moles of N2 is 4 moles. Calculate the relative formula mass, or MR, of NaN3. Relative formula mass is the same as relative molecular mass, but this is for ionic compound. Once again, if the AR values of elements are not given, you have to find it from the periodic table. In this case, the AR value of Na is 23, and the AR value of nitrogen is 14. So 23 times 1, because the number of sodium atom is 1, plus 3 times 14. The number of nitrogen atom is 3. So it's 65. So the MR value of NaN3 is 65. 23 plus 3 times 14, 65. Next, calculate the mass of NaN3 needed to produce 144 cubic decimeters of N2. So remember, we have to calculate the mass of NaN3 needed to produce 144 cubic decimeters of N2 to produce 6 moles of N2. The moles of NaN3 is already found. It's 4 moles, and now we have to find the mass of NaN3. Mass equals to moles times MR of NaN3. Remember, we have to use this formula, moles equal to mass divided by MR. This one. So to find mass, we have to multiply the number of moles by MR. 4 times 65, it's 260 grams.